Dual Inline Memory Module, DIMM. Think of the Dual Inline Memory Module, or DIMM, as the massive industrial warehouse of your computer's memory system, while the SODIMM we just discussed is the compact version built for mobility. The standard DIMM is the full-sized, high-capacity powerhouse designed for the desktop workstations and servers you'll be building in your home lab. To master this for your CompTIA A+ exam and your CIS classes at BCC, you must understand why we call it dual inline, how to identify the different generations by their physical notches, and how to leverage multi-channel architecture to squeeze every ounce of performance out of your hardware. The name, why dual inlined? To understand a DIMM, you have to know what came before it. In the early days of computing, we used SIMMs, or single inline memory modules, on those old sticks. The electrical pins on the front and the back were tied together. They sent the exact same signal. A DIMM is dual because the pins on the front side are electrically independent from the pins on the back side. This essentially doubled the amount of data that could be moved across the module at once, moving from a 32-bit data path to a 64-bit data path. Every modern desktop computer you touch today uses this 64-bit DIMM architecture. Physical characteristics, the desktop standard. The most striking feature of a DIMM is its size. It is roughly 5.5 inches, 133 millimeters long. This larger real estate allows manufacturers to pack on more memory chips and, more importantly, specialized heat spreaders. Because your home lab server might be running heavy local AI models or complex virtual machines, the DIMMs will generate significant heat. Many high-performance DIMMs come wrapped in aluminum heat sinks to pull that heat away from the chips, something you rarely see on the tiny SODIMMs inside a laptop. Generations and the key notch. Just like the laptop versions, desktop DIMMs have evolved through generations from DDR3 to the modern DDR5. Each generation is physically incompatible with the others. For the exam, you must remember that each generation has a unique pin count. DDR3, 240 pins. DDR4, 288 pins. DDR5, 288 pins, but with a different pin layout and internal power management. The most important physical detail is the notch. Every generation has a plastic cutout in the pin row located in a slightly different position. This keying ensures you can't accidentally force a DDR4 stick into a DDR5 motherboard. If you try, the notch won't line up with the plastic riser in the slot, preventing you from seating the RAM and potentially frying your expensive MSI motherboard. Multi-channel architecture, doubling the speed. The biggest advantage of using full-size DIMMs in a desktop is the ability to use multi-channel memory. Most modern motherboards support dual-channel or even quad-channel configurations. This allows the CPU to communicate with 2 or more sticks of RAM simultaneously, effectively doubling or quadrupling the bandwidth. As a technician, you'll notice that the RAM slots on a motherboard are often color-coded, for example, 2 black slots and 2 gray slots, to enable dual-channel mode. You must place your DIMMs into the matching colored slots. If you put them side by side in mismatched slots, the computer will still work, but you'll be stuck in single-channel mode, which can significantly slow down your cybersecurity tools and AI processing. Comparison for the A+ exam. To lock this in for your certification, remember these 3 contrasts. DIMM versus SODIMM size. DIMM is the full-size desktop version, approx. 5.5 inches. SODIMM is the half-sized laptop version. DIMM versus SODIMM, data path. Both are 64-bit, but DIMMs are easier to configure in multi-channel arrays due to the extra space on desktop motherboards. Compatibility. Always check the notch and the pin count. Never assume a stick will fit just because it looks similar to the one you're replacing. By mastering the DIMM, you have the knowledge to build and optimize the high-powered workstations that will serve as the backbone of your cybersecurity career.